Hello Science 30s. This video is going to be on atomic basics and some nuclear notation as well. So something new and something a little bit old. So first of all, if we just get into the atomic basics, we all know that all matter is made of atoms, and those atoms have protons, electrons, and neutrons. Protons are and neutrons are going to be in the nucleus, and the electrons are zipping around outside that nucleus. The two things that we need to worry about when we're talking about these are the mass and the charge. This is what you would have learned in the past. This is going to change a little bit today as you go through the next few videos. But basically, we need to understand protons have a mass of 1 and a charge of 1 positive. Electrons have a mass of 0 and a charge of 1 negative. And neutrons have a mass of 1 and 0 charge. And so when we look at this now, guys, we can start to take a look at what's going to happen with some of these numbers as we look at different elements. So for example, if we take a look at beryllium here. So beryllium. Now, what we see here is we see that beryllium here is this. There's the symbol. There's the name. And this is from your data booklets, by the way. Here, up here, is going to be your number of protons. That is also equal to the atomic number. So and then down here is the mass number. And so that's going to be equal to the number of protons and neutrons. Now, so the way we would write this, if we were writing this in written form, in word form, sorry, would be beryllium. I think I spelled that wrong. Yeah, we need another L there. Beryllium 9. That's the way we would call that. And we get that 9, we get this 9 here from this 9 here. And so that's beryllium 9, which means it has a mass of 9. Now, if it has a mass of 9, 9 is going to equal the number of protons plus the number of neutrons. And so what that means then is that we already know the number of protons, though. That means that 9 is going to equal the number of protons. Now, this is number 4 here. Is this number 4 here? Remember that you can never change the number of protons. If you change the number of, if you had a beryllium, if you had a whole bunch of beryllium or something, and you were able to add a proton into every single one of the nuclei in that beryllium, you wouldn't have beryllium anymore. You would have the next element in the periodic table of elements, which is why don't I have that memorized? I should. So you would have boron at that point. Okay, and if you took one proton out of a nucleus of beryllium, then you would have lithium, because you would have 3 protons then. So don't forget, guys, that protons, as long as you know the element, you know the number of protons. And then we just go like this, and this would be the number of neutrons right there. And so obviously the number of neutrons is going to equal 5. Another thing that we should go over here, guys, is that the number of protons and the number of neutrons together are called nucleons. So that's a word that may come up in your week as we do go through this atomic stuff. And so nucleons is going to equal the number of protons plus the number of neutrons. So it's essentially equal to the mass number. So the number of nucleons in this beryllium would be 9. Okay, let's do one more example. Let's do magnesium. So maybe you guys can pause the video here if you want. Take a couple minutes and break it down. How many protons? How many neutrons? So assuming you've done that now, what we're going to do is we'll take a look at this. So we have magnesium, which is big M little g, and then we have the mass number right there, and we have the atomic number right there. So if we were to write this out in word form, just to practice this out, this would be magnesium, and then we go with our mass number, 24. Now, so then what we're going to be doing is we're going to say, okay, well, 24, which is the mass number, is going to equal the number of protons plus the number of neutrons. And so therefore 24 will equal, now my number of protons is right here. That's equal to 12. And in this case, obviously the number of neutrons is going to equal 12 as well. I just kind of did that step all in one there, because 12 and 12 is 24, obviously. And so there's our number of neutrons. Okay, and that's really important to know for this unit. Now that we have this information, one thing that we really want to be able to do is communicate this across the world to everybody, and so in an international way. And so the way that we do this, guys, is nuclear notation. What we're going to be doing is just using the symbol. So for this beryllium 9, what we're going to do is we're going to put the beryllium up there, the 9 is going to go up there, and then the atomic number is going to go down there. And so nuclear notation is a really quick and usually easy way to just try and figure out how many neutrons you have as well. Here's your mass number is right here, also equal to the number of nucleons if you want to think about it that way. Here's your number of protons, 9 minus 4. Okay, so let's write that down. 9 minus 4 is equal to 5. So this is equal to the number of nucleons. This is equal to the number of protons, and then this is equal to the number of neutrons. So once again, guys, go ahead and try that for this magnesium now. So for the magnesium, you should have magnesium like this. The mass number is 24, the number of nucleons is 24, and the number of protons is 12, which means that my number of neutrons, is also 12. So there is nuclear notation. What I want to do, one last question with you here, guys, just to practice this once again. So write the following isotopes in nuclear notation. So once again, guys, an isotope is an element that has the same number of protons, but a different number of neutrons. So if you want to go ahead and try this, go ahead, please. So now what we're going to be doing here, guys, then is carbon 14. So carbon 14 right here, right there, there's our 14. What's going on here? There we go. There's our 14, and we're going to compare that to carbon 12. Carbon 12 is the most common carbon. Carbon 14, though, is out there, but it has a very predictable half-life, and this is how we're able to often determine the age of bones and fossils that we find. So we can go to this right away and just figure this out. So with number of protons, first of all, the number of protons here is going to equal 6, and the number of protons here will also equal 6, because it's both, in both cases, it's going to be carbon. The mass number, or the number of nucleons, we're just going to go number of nucleons. That is more the accepted way of talking about it when we're in this unit. So here's the number of nucleons. The number of nucleons is going to equal 14 here and equal 12 here. Okay, so the number of and really, actually, this point for nuclear notation, guys, actually, we don't even need to go through all this work. All we really need to do now is put this in. So carbon has, the number of nucleons is 14, and the number of protons is 6. So therefore, the number of neutrons would equal 14 minus 6, which is equal to 8. And on the other side, it's going to be carbon 12 up here, 6 down here. So the number of neutrons would equal 12 minus 6, which is equal to 6. And so that's just an important video, guys, first of all, just to show you how to use nuclear notation.